Algebra students, I'm excited to bring this lesson to you. Circles. Graphing circles. Circles seem like they must be infinitely more complex than graphing straight lines. Why are we starting with graphing circles instead of straight lines? Well, if you can remember anything from algebra, you remember that all of the function families that we deal with essentially act the same way. And if you can remember that, graphing circles winds up being one of the easier functions that you can graph. So number 4, you're going to graph circles. And then learning target 5, you're going to do a little bit of algebra, a little completing the square to calculate the center and radius of a circle. So this one should be relatively quick compared to some of the others. So I guess first of all, what is a circle? Well, a circle technically is the locus or set of points from a point or a center. Okay, and so if you think about it, so here we've got like the Cartesian coordinate grid. If I had a point here at the origin, a circle would just make up all of the points that were equidistant. So I guess I forgot that word here. Set of points equidistant. So of equal distance from this point. Okay, and one thing that I want you to notice is that, well, we could kind of figure out the length from the center out to the circumference by using the Pythagorean theorem. So if I kind of drop this down, kind of drop that down over here, maybe I should just do that in a different color. What you can see pretty quickly here is that, well, this distance right here would be the x, and this distance right here would be the y. And how could I find this distance right here, also known as the radius of my circle? Well, it would just simply be x squared plus y squared equals r squared. And that is one of the bottom line things that you're going to need to know. And so the general equation for a circle at the radius, where the center is at the origin, is just simply x squared plus y squared equals r squared. Okay? And that'll give you the coordinates for all of these points that are on the circle. Well, of course, we don't have all circles with a center at the origin. Sometimes it moves around. And so how are we going to shift it? Well, the circle radius form is how we do that. And so I'll say x minus h squared plus y minus k squared equals r squared. So the h and the k are what shift it left and right. So here, the h value, okay, essentially moves it to the left and to the right. Okay, if my number is positive, it moves it to the left. If it's negative, it moves it to the right. And the k value moves it up and down with the y. And if it's positive, it moves it down. If it's negative, it moves it up. So it's the opposite of what you would kind of expect it to be. And that's reflected here. So, if my h value is positive, it's going to be x minus a positive, which means, it's going left. All right, we have another general form which is not nearly as helpful. In fact, it's really not helpful at all. Here I can see exactly how it's going to move left and right or up or down. I can tell what the radius is going to be by just taking the square root of this number. We have another form, it's called general form, and it looks like this: x squared plus y squared plus cx plus dy plus e equals 0. I'm not really able to tell anything about this. So it's not real helpful. But if you get something in this form, well, I'll show you what we do with it in a second. We have three possibilities when we are graphing these circles. And so if I wind up with r is greater than 0, I'm going to wind up with a circle. Okay, so that's basically it. If r is equal to 0, well, that means my radius equals 0, which means I just have a point. And if my radius is less than 0, well, I can't have a radius less than 0. That means it does not exist. So those are my three possibilities, and I'll just be able to look at that here. All right, let's move on to some examples. All right, so this is learning target number 4. Find the center radius form of the equation of the circle described, and then graph it. So I've got a center at -3, +4. So if I were to write that out, it'd be x, well, it'd be minus -3. So plus 3 squared plus, and then I'm going to have y minus +4. So y minus 4 squared. And then my radius is 6, so 6 squared is 36. All right, there's my equation. But this is now not going to be difficult to graph. I've got -3, +4 is going to give me a point right there. I've got a radius of 6, so I'm moving over 6 here. I'm moving down 6 here. I'll be a little bit off the graph here and a little bit off the graph here. But you can see that I have a nice, ugly circle right there. All right, next one. I've got a center at 0, 0. Okay, so if I'm writing out the equation, I've got x plus 0, which is just x, so x squared, and then y minus 0, which should just be y squared, and then a radius of 3, 3 squared is 9. So when I go ahead and graph it, I've got my center at the origin, and then I've got a radius of 3, so I'm just going to do kind of the 3 keys and connect them, and that was a little better circle. All right, and I'm done. That's graphing circles. All right, here we go. Here is that ugly standard form. Here's what you do with it. Says, show that it has a circle as its graph. Okay, that's fine. And then find the center and the radius. Well, I can't tell any of that right now. So what I'm going to do is I'm going to actually kind of split this up a little bit. I'm going to say x squared minus 6x. I'm going to give myself a little space, plus y squared plus 10y. Give myself a little space. And then I'm going to subtract 25 from both sides, and I get -25. Now, before you get all carried away and say there is no solution, just hold on to your horses. Here's what we're going to do. We're going to pretend like this is part of a completing the square question. So if I wanted to complete this square, half of -6 is -3. -3 squared is +9. And so now I have completed the square for this little section. And so I can turn that into x minus 3 squared, which is nice. That kind of takes me back to that radius form. But of course, you all know that if I add 9 to the left, I have to add 9 to the right as well. You can maybe start to see why this might wind up being a circle. I'm going to do the same thing over here. Half of 10 is 5. 5 squared is 25. So I add 25 to make this a perfect square trinomial. And that'll wind up being y plus 5 squared. And of course, if I added 25 to the left, I have to add 25 to the right. And on the right-hand side total, I wind up with 9. And so I do have a radius. That would be the square root of this. The radius is 3. And so since it's positive, that does mean I have a circle. And what is the center? Well, the x value is going to be the opposite of this one. It's going to be 3. And then it's going to be, again, the opposite of this one, negative 5. All right, so there's where my center is. All right, all that is good and fine. Let's go ahead and take a look at this last one. It says the graph of the equation, blah, is either a point or non-existent. So we're not even pretending to say that it's a circle. We just want to know, is it a point or is it non-existent? Is it 0 or is it negative for the radius? Well, we're going to probably have to do the same process as we did last time. X squared plus 10x, give myself a little space there for the completing the square part, plus y squared minus 4y, again, give myself a little space, and then equals negative 33. Subtract that from both sides. All right, half of 10 is 5. 5 squared is 25. So I add 25 to the left, I add 25 to the right. And then I take half of negative 4, which is negative 2. Negative 2 squared is positive 4. And so if I added 4 to the left, I add 4 to the right. Now this all winds up being something like x plus 5 squared. Over here I wind up with y minus 2 squared, which is kind of neat. If it had a center, it'd be at negative 5 too, but take a look at this one. This is going to give me, when I add 25 and add 4, negative 4. I have a radius that would be negative 2. And negative 2, not going to happen for a radius. So this is non-existent. All right, well, that takes us through circles. All right, here you go. You got learning target 4, learning